Today we're going to solve quadratic linear equations using an algebraic method. You can use the date of May 20th for your notes, and this will be the last lesson for this huge unit. Your notes are 2 pages today. When you solve a quadratic linear system, you're going to be presented with 2 equations. At this point, you should be able to identify which one is the quadratic equation and which one is the linear equation. So once you've identified which one is which, we want to take the linear equation and set it equal to y. So you want to have it in slope-intercept form. And then what we're going to do is substitute the linear equation into the quadratic equation. Since both of them will be set equal to y, we can easily sub in. Once you've subbed in, we're going to start moving our terms around. We want to put any like terms together, but we also want to make sure that the quadratic equation is in standard form, and we still want to try to keep our quadratic term positive. You can solve your quadratic equation using any method. I always try product sum first. If that doesn't work, I typically go right to the quadratic formula because it never fails. Once you've obtained your roots, you could have 1 or 2 options. We're going to sub those x values into the linear equation. When you sub them into the linear equation, what you're going to get are the y values. So the quadratic will produce the x's, the linear will produce the y's, and you'll have the ordered pairs where both equations intersect. I would recommend using a graphing calculator to check that each ordered pair is a solution. You can bring up the table. In some cases, though, if the intersection is not at an exact location, more of a decimal or fractional location, the graphing calculator may not give it to you in the table, but visually on the graph you can see it. So in example number 1, the top equation is quadratic. I see x squared. The second equation is linear because I have x to the first. What I want to do is rearrange my linear equation so that y is all alone. So I'm going to add 1 to both sides. And now that I have a value for the linear set equal to y, this portion, 2x plus 1, is going to get subbed into the quadratic in place of y. So when you write it, the left side is the linear, the right side is the quadratic, but we're going to combine our like terms. So I'm going to subtract 2x from both sides, and I'm also going to subtract 1 from each side so that my quadratic is set equal to 0. I think this one is factorable by product sum. I need 2 numbers that multiply to 8 and also add up to -6. So I know that my binomials are x minus 4 and x minus 2. That will give me a root or a solution at +4 and +2. So the quadratic equation told me the x values for my intersections. Now what I'm going to do is sub into the linear. I'm actually going back to the original linear equation, and I'm going to start by subbing in 4 for x. And I'm going to go ahead and work through this, and y is 9. So 4, 9 is an ordered pair that they share. Now I'm going to sub in 2 for x and work through this problem, and I get y is 5. So my quadratic and linear system will intersect at 4, 9 and 2, 5. You should double check this on your iPad or your calculator to see the graph, but you'll see these are exact locations and those should show up in your table of values. In example 2, this is my quadratic and this is my linear. It just so happens that the linear equation is already in slope-intercept form. So I'm going to take x minus 1 and I'm going to sub it right in for y. So I'm going to go ahead and subtract x from both sides and then add 1. And again, this one is factorable by using the product sum method. both of my factors are identical. They're both x minus 1. That tells me I'm only going to have one root. So now we'll take this value of x and we'll sub it into our linear equation. And when I do that, I get a y value of 0. So the quadratic and linear system for this problem only intersect in one location, and their intersection is at 1, 0. And again, when you graph this on the iPad, you should see that the line just touches that quadratic in one spot. Here's example number 3. Remember, the top one is the quadratic, the bottom equation is linear. I'm going to rearrange my linear equation to isolate y. So I'm dividing every term by 2. And I do have a fraction at this point. I'm going to sub in the linear to the quadratic. And I'm going to subtract 1/2 x, and I'm going to subtract 2 from both sides. And this is the resulting quadratic equation. Now, you can convert -4.5 to -4.5, but factoring a decimal is not going to be easy. So automatically, I'm going to use the quadratic formula. So remember, it's x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. You should not get a negative number underneath the square root radical. If you do, you have made a calculation error. I'm going to simplify what's underneath the square root radical. And I'm going to go ahead and subtract. I know that 3.5 is not a perfect square. So I'm going to go ahead and separate this, and I'm going to obtain decimal values so that I can sub into my linear. So the first factor will be 4.5 plus the square root of 3.5 over 2. I'm just going to go ahead and put that into my iPad, and this is my decimal value. We'll do the same for the subtraction factor, and I'll put it into my iPad. I'm not rounding it off at this point. I'm going to leave all the decimal places. When I sub it into the linear equation, I am going back to the original. So the first time I'm replacing x with 3.18541. And now I'm going to divide by 2. And logically, we're getting another decimal. Let me sub in the factor of 1.31459 for x. And as I work through it and divide by 2, there's my other y value. So this ordered pair does exist. There's 2 points of intersection. They're not at integer values, but that's okay. They're not always going to be. Now in the solution, I did round off to the nearest hundredths place. If the directions tell you to round off to the nearest tenths, you could do that as well. Just some kind of decimal place because it's not a whole number. This is homework number 119. You'll find this in your packet. It's 2 pages long. I think it's 8 problems. If you have any questions as you go through this assignment, please make sure you get in contact with me. And if the worksheet comes up weird, make sure you let me know that too. Have a great day.